Hello, I'm James Ingram for AutoControls.org. 2 videos ago, in video number 820, we looked at the DCC DCS switch that's found on MTH O-Gauge Proto 3 locomotives. And then in the previous video, number 821, we used an NCE brand DCC Power Cab to operate an MTH O-Gauge locomotive. In this video, we'll use that same power cab plus an NCE DCC automatic train controller, also known as a mini panel, to automatically operate a Proto 3 locomotive running point to point, and that'll be done on this little display that you see behind me. And we'll do 2 demonstrations, one using a single reed switch as a detector, and the second demonstration will use a single Z-Stuff infrared block signal detector. In the next video after this video, we'll use a Z-Stuff infrared detector at both ends of the point-to-point layout, so we can have separate forward-back buttons that the public will be able to operate this as an option. And that'll be previewed in section 10 of this video using an S-gauge locomotive. Now I have to put in a warning. NCE says not to use this power cab on O-gauge trains because it's too low of voltage and too low amperage. However, I had already recorded this video and it seems to work fine, so I'm using it. Finally, this is also the same video almost as previous video number 818, where we were doing automatic point-to-point operations using an HO gauge, an S gauge, and a large-scale locomotive. But in this video, we're just doing the same thing, but now we're showing it with a 3-rail O-gauge locomotive. Thanks for watching. Now what we've got here is an automatic point-to-point operation using what is called an NCE Mini Panel, which is this little device right here, which is essentially considered a simple programmable controller for DCC model trains. It does need to be used with an NCE system. It won't work with Digitrax or Lens or the other systems. It's got to be used with an NCE system, but it works fine with the power cab or, of course, the larger systems. But basically the principle is when we start this engine up, the mini panel will send a command for the engine to go forward for about 13 seconds, which will take it down to the end of the track. It'll stop and it'll sit there for about 7 seconds, and it'll return until it gets back here. And there's a reed switch in the track about where this yellow note card is, right underneath that gondola, and then there's a magnet hot glued on the bottom of the gondola, and we use that reed switch to sense when the train has come back. It would be more, you can make a more accurate system by putting detectors at both ends, but I was trying to make the wiring as simple as possible for this, so we're just using one detector and using time to approximate how far out we want to go before we come back. And let's turn this on and we'll demonstrate it here. I'm going to push function 3 to turn on my locomotive. And when I close this switch, I'm just going to actually touch this switch, but that's the same effect as pushing a button. I don't have a button here, but I've got this switch, but I can use to simulate a button. So let's touch that switch, and that starts the mini panel going. It sent a command for the loco to go forward at speed 2, and it's going to go down there, like I said, for about 13 seconds, and then it'll stop and sit there for a minute. And all these speeds and times are adjustable within the mini panel depending on how you program it. Now it's coming back in reverse, and it'll come back until it crosses over the reed switch. Now it's stopped. Now it's going to sit there again because the thing is programmed to look to see whether this switch is closed or not. And if it's not closed, it'll wait till somebody comes along and pushes the button again. The idea is like you could have this type of display on a club layout or a public display, and your engine's sitting there with the sound and the lights on, so you've got some action, but you're not putting any wear and tear on the drivetrain while it's not in use. And then when somebody comes along and pushes the button, it'll go into action. So now the other way we can run this is we can push the switch closed and leave it closed, and that way the thing will keep repeating. So now it's doing the same thing. It's going to the end. It's going to go for 13 seconds and stop, and then it'll wait at the end for a minute and come back. And notice this thing, the amperage, if it shows up on the camera, it's pulling about 1/3 of an amp or so. It's not pulling much amperage just to push one car at slow speed. Okay, now we're back and we've stopped, and notice the amperage drops off to about 0.16. Because that switch is closed, it'll repeat the sequence. And these are all simple commands, like speed forward 2 is what command started it down there now. And then a delay statement, which means just do nothing, delay for 13 seconds. Then when and then it issues a speed 0 command, which means stop, and then a delay statement to wait. Now it issued a speed reverse 2 command, and it's coming back and it's waiting till it crosses the read switch, and when that happens it issues a speed 0 command. Now that'll start up and go again because I've got that switch closed. So it's given it a speed forward 2 command. Of course you can adjust all this, but it's now it says delay for 13 seconds, do nothing. When 13 seconds expires, it says speed 0, which is what you see now. It's parked. It says delay 7 seconds. Now it's coming back, speed reverse 2. Now it's waiting until that read switch gets closed. When the gondola goes over the magnet, then it'll stop again. And this will keep running all day like that. Now if I open the switch, it'll sit there and wait until somebody comes along and pushes the button. Now you could say, you can set up something like this in DC using a timer that reverses the polarity every so often, and you put diodes at the end. We actually demonstrated this in video 666 using DC engines. And you might say, why go to all this complexity and expense to do what you could do with a simple reversing timer? Well, the main thing is with this you get a lot more flexibility. You get the sound and lights while you're parked, plus you have the option of adding turnouts and doing other types of things. Let's take a closer look at the control part of this. This little board here is what we're referring to as the mini panel. It's like a $49 off-the-shelf item from NCE. You can think of it as like a robot holding a robot holding a cab. It doesn't send any power or anything out. All it does is sense things through these inputs, like a read switch in this case, and then it sends commands back out over the control bus, which is this wire going out here. So at any rate, this is our mini panel, which is our controls. This is a reset button to reset the mini panel if we need to. This is that switch I was using. I was also simulating a push button, and then this is nothing here. So basically what we've got is the mini panel's the center of this board. Out here in the track we've got a read switch, which is this black thing that I've got taped down with this orange duct tape. And the read switch essentially looks like this. A friend of mine, Mark Anderman, made some of these up. He took a naked read switch, the fragile glass bulb they give you, and he put like a support on it and some tape to make it kind of more secure, and that's what I put in between the rails. And then the magnet on the car, this car has the magnet. Let's bring that over here. This is kind of crude, I'm sure, as far as mounting this read switch and mounting this magnet. Other people can come up with better ways to do this than me. I just cobbled this together enough to make a test, a demonstration. But here's our car. This actually has a piece of wood on it to bring the bottom closer to the track, and then a magnet hot glued on the bottom of this car. So when this magnet on the bottom of it, and I tried to position the magnet over on this side of the car so it lines up over top of the reed switch as close as possible. So when this magnet passes over this reed switch, it closes the reed switch, which is wired, I think it's input 14 on the mini panel, and it can sense that, and that's how it sends a signal to stop the train when it's coming back. This mini panel has a little red LED right where I've got my finger pointing, and if I push the reset button, it usually causes that to blink. I hope it shows on the camera. That's blinking, and that'll also blink anytime the mini panel sends a command. Now there's a test routine running in that right now to test the reed switch. And when the reed switch is closed, it'll just send dummy commands. Actually, I'm telling it to throw a turnout that doesn't even exist, but I'm sending a dummy command just for the purpose to make that mini panel blink. So let's roll this car and get the magnet. Now we'll roll this car over top of the reed switch, and hopefully it shows up on the camera. When that magnet on the car is over top of the reed switch, this thing is blinking continuously, and like I say, it's just a test routine that tells us that the mini panel is sensing the reed switch and can detect when the magnet is over top of the reed switch. Now if I roll it away, as long as I keep the car there, it keeps blinking. If I roll it away, it stops sending those commands. Again, if I bring it back over the reed switch, it starts blinking again. And likewise, I can also test that same routine is set up to test the button or the switch, whichever you have hooked in here. You can see when I close this switch, it also blinks that. So you can write a little test routine to test your different inputs and make sure the mini panel is sensing them. And of course, if you take this reed switch and hook a ohm meter across the two leads of the reed switch, it'll detect, it'll show on the ohm meter also, but you can't do that while it's hooked up. So this routine is easier to use while the reed switch is hooked up to the mini panel. As I mentioned, when a magnet crosses this reed switch, it closes a reed switch. Essentially, it's like closing a push button or closing a switch. It connects a circuit and connects terminal 14 to ground, and we can simulate that effect just by using a wire and connecting terminal 14 to ground. I'm going to try to do that now. This is my ground. These three are grounds here, and if I connect terminal 14 to ground with the wire, you can see that mini panel starts blinking. Actually, I'll go back on the panel itself and do it. These three are ground terminals in the center, and I'm going to connect it. I think I did put 14 there. You can see I've got the ground, which is my right hand, and on the left, my left hand is holding the wire on terminal 14. So basically all this thing does, it has basically 31 terminals that you can use for sensing. And when you connect a terminal to ground by either a push button, a switch, or a reed switch, the mini panel detects that and does whatever command you tell it to do. So as I mentioned earlier, it doesn't send out any power. All it does is detect things and then send a command out on the command bus, and it's like a robot holding a cab, just doing operations for you automatically. Now we've disconnected the reed switch, and we've replaced that with a Z-Stuff DZ1011 block signal detector, and that's wired to behind it, which is kind of out of sight, but back here is a Z-Stuff DZ1008 relay, and together those two units perform essentially like a reed switch. And they can be wired into the mini panel identically. I didn't have to change anything over here on the wiring. I just disconnected the two wires from the reed switch and connected these two wires here, which go over to the relay, and this thing is powered off of track power. I have it connected in down here to track power. It doesn't have to be track power to power the Z-Stuff detector, but just some source of power. But this makes the it's more wires. The reason I did the reed switch originally, I wanted to hook it up as simple as could be from the wiring standpoint. Now when we change and remove the reed switch and add this Z-Stuff detector, we're making more wiring in the sense we got to hook up the detector to the relay, but that's a simpler operation. You notice the car with the magnet is off the track. We don't need that anymore. So we don't need a magnet. We don't really need the reed switch. How this works is the Z-Stuff detector sends out an infrared signal on about 45 degrees so that when something blocks a detector, it'll change to red, and then a second later it'll change back to green. So I pulled that gondola just ahead of it so it's not detecting it, but when that gondola comes back and it crosses in front of that detector, it'll change from green to red, and the Z-Stuff relay will close. The detector will cause the relay to close its contacts, which is the same thing as the reed switch having its contacts closed, and that'll signal the mini panel, our controller over here, that the train has arrived back. Now we'll start this engine up. I'm going to push function 3 to turn our engine on. Now we'll activate the mini panel. And same as before, you can see it's started that engine up at speed step 2, and it has a delay statement of about 13 seconds to get it out toward the end of the track. Now it's got a delay statement to stop for a few seconds. Now it gave it a speed reverse 2 command to back it up, and it's waiting until that contact input 14 is closed. There it goes. You can see the Z-Stuff detector went from green to red, and that alerted the mini panel to stop the train. Now the mini panel gave the train the forward command again, and you can see the Z-Stuff detector went back to green. And now we're just repeating this process. This time I'll open the switch so it'll stop the cycle when it comes back. Now again, when that gondola cuts in front of that infrared signal, it's invisible, but when that cuts in front of that infrared signal coming out of that detector, the detector will change to red. The relay will close. Relay's contacts will be closed, which will tell the mini panel that the train has arrived, and it'll stop. And since I've opened the switch, it's just going to stay there. This means this is easier because you don't have to worry about putting a reed switch in the track, and you don't have to worry about you eliminate the reed switch in the track, you eliminate having to put a magnet on the car, and you can easily move this thing around to a different position. If I want to relocate the reed switch, I got to untape it and move it. Whereas this thing, you're not in the track at all. It's just alongside the track, so it's much easier to move it around or relocate it. We'll take a look at this Z-Stuff detector and relay from another angle. Here it is. This is the detector. Here's the relay and the wires to connect them together, and I'm sure most of you can probably do this neater than I did. But we have 2 wires coming in for power. That's these 2 wires here, and they go back over here to where the track power is connected to the power control panel. So that's what's powering this detector. And then we've got 2 wires coming out, which are the normally open contacts of the relay, and those 2 wires go over here and connect to the mini panel. Again, we connect to the same terminals as the reed switch without having to change anything. And the only thing you got to be careful of, you got to make sure you don't mix up the power from the relay output, because the one thing you can do to damage this, according to NCE, is if you put power into these input terminals. Remember I said earlier, all this thing does is just gets a terminal connected to the ground from like a push button or a relay or a read switch. You never want to put power on these. You're just connecting a terminal to ground, which enables this thing to detect that something has happened. So we got to make sure we don't mix up our power with our relay output. Take another look at the other side of this Z-Stuff detector. I disconnected the wires to the read switch so I can kind of lift it over toward the camera here, but I've marked this as clearly as I can to try to make it idiot-proof for myself. My power is over here. You can see it says PWR in red, and I've got plus and minus in yellow. That tells me that's where I hook up to the power to this thing. And over here, the NO is normally open and the C is common, so these two terminals are where the relay output goes over to the mini panel, just to stay safe and not have any chance of connecting power to the mini panel, which, as I said, could damage it. Here's what we'll plan to do in the next video. We'll set up a similar system, but we'll put a Z-Stuff detector at both ends of the track, not just one end of the track as seen in this video. So we'll have the same operation we already showed. You can present a button like this to the public. It says push and release will make one forward and back trip, which is what you saw earlier in the video happening when we pushed that switch like a button. The train went down to the end of the track, stopped, came back. But we can also, with having two Z-Stuff detectors, we can present to the public optionally these buttons that'll actually be pushed to make the train run. In other words, if you push this button here, it'll make the train go in forward direction. If you release it, it'll stop. If you push this direction, it'll make it run in the reverse direction. If you release it, it'll stop. And then having a Z-Stuff detector at each end, it'll automatically prevent the train from going past that detector. In fact, it'll ring the bell to indicate that the train is up the detector and can't go any further. The idea is what a lot of times small kids seem to enjoy, a train they can actually make it run themselves, and this is something you could present for the kids, that they could run the train themselves back and forth, but they couldn't do any damage or run it off the end or anything. So you can present either sets of these buttons, and the mini panel will adjust to whatever button is being presented. If you present these two, it'll do this manual operation. If you present the first button we showed at, this one, it'll just, when you push this button and release it, it'll automatically run one cycle back and forth. So there's no adjustment needed other than just presenting the proper buttons. And of course you can use the switch. The operator has the option of closing that switch, which will make it run continuously back and forth. So you really have three modes of operation available to you. This next clip was made several months ago before I got the O-gauge engines. It shows an S-Helper service S-gauge engine operating with this two-button system like we were talking about that the public could operate. The S-Helper, the Soundtrack Tsunami decoder is what's in the S-Helper engine, and that's a nice unit because it can be programmed to automatically give 2 toots when you start up in forward and 3 toots when you start up in reverse. Plus it has the output to drive the flashing beacon on the cab roof. So now the buttons will act to control the train manually. If the public holds down this button, it'll go forward. If they hold down this button, the train will back up. So you can see that here. If I hold that down, it starts forward. If I release it, it stops. And if I hold this button down, it starts in reverse. But if I release it, it stops. So this is a way, if you so desired, you could put a couple of push buttons out and actually let the public control the trains. Now let's hold this button down and take it all the way down to the detectors. What happens is when the detector gets blocked, it senses that and it stops the train. Even though I'm holding the button, it won't let the train go any further. It just rings the bell. Of course, the bell ringing is optional. That just tells you went as far as you can. Now if the public pulls the reverse button, it allows them to back it up, and it'll allow them to back it up until it blocks this detector on this end, and the same thing will happen. It'll stop the train so it can't go off the track, and it will ring the bell. So like I say, what you've got here is a manual mode where the public can control this thing, but they can't run it off the end. So you can switch. Here's video 815, which is a 5-part video titled Beginner Exercises for NCE Mini Panel Automatic Train Control. In this video, I gave it my best shot trying to explain how to program and use the mini panel. And this is a fast-forwarded Part 1 preview, but I went through putting in the steps and then did some simple demonstrations like you see here. This is compilation video number 611. It has excerpts from 18 videos. The first 9 are analog, and the last 9 starting at about the 7-minute point, or DCC. Here's one of them where we were operating an automatic 3-track yard with the mini panel. The mini panel's in here on this board, and here's the power cab operating it as before. You can see the power cab's power supply over here. So this is one thing the mini panel does very well, is controls multiple sidings like this. Here's a video 819 made after the compilation video was made. This is interesting. It shows the same mini panel here and the same Z-Stuff detector controlling 3 HO trains on the same main line without using any turnouts as far as the control scheme. And the logic here, as it's explaining now, and these are speeded up, by the way, 500%, just so things happen faster. The logic here basically is you have 2 trains in the yard creeping and 1 train on the main line. And with the train on the main line, that's a shark nose coming around here, crosses in front of the Z-Stuff detector. You reduce its speed to a creeping speed, and you speed up the forward one out of the yard. So it's kind of like each train takes its turn making a fast loop around the layout, and the other 2 trains, you kind of hold them creeping in the yard. And the trick is you got to have the front one in the yard creeping a little bit faster than the rear one in the yard so it doesn't catch up to it. The drawings and commands for this video are on the website. If you go to AutoControls.WordPress.com, which is part of AutoControls.org, and you scroll down someplace, there should be a link to video 820. Here it says video 820 notes. And if I click this link, it opens a new window, and we see some pictures. There's a couple pictures. Here's the wiring diagram, the hookup for the Z-Stuff detector, and part of the command file, plus a lot of advertisements because this is on a free WordPress.com web page. Here's the wiring diagram for this setup. Up here in the upper left, we show a powerhouse. In the video, we use the Power Cab, but it could be either one. But this red and black wire shows the DCC track power coming out of the Power Cab in this case and going down to the track. And then we have a control bus going from the command station over to the mini panel. And then here's our mini panel right here, and we've got a Z-Stuff detector hooked up over here, as was shown in the video. And we've only got one on what I'm calling the west end, the left side. There's no east end detector. We're using time delay to control how far the locomotive travels east. This isn't as precise as having a detector on both ends, but it simplifies the wiring. And then we've got a a reset button here. You use this to reset the mini panel. Here's the switch that showed up in the video. If the operator touches a switch like I did in the video, it kind of acts like a push button, and the local will make one cycle. If he closes this switch, the local will continue to go back and forth. And then out here in parallel with this switch, we show a push button you can put for the public if this is on some kind of a public display. If the public pushes this button and releases it, the local will make one back and forth cycle and come back and park and wait. So the idea is your local's not running back and forth continuously. If there's nobody watching the layout, it won't be wearing itself out when nobody's watching. Now over here is the Z-Stuff hookup in these dotted lines. This dotted boundary I drew around this thing kind of defines it as a unit the way I assembled it. You've got two wires coming into it for power, and I show them off the track, but it doesn't have to be. It just needs AC power from somewhere, and then two wires coming out of the relay that go over to the mini panel. And as I mentioned earlier, the mini panel sends out no power and it receives no power on any of its input terminals. All it does is looks for an input terminal to be grounded, which it can detect. For example, we've got this detector hooked up to input terminal 14 as it shows here. So when the relay contacts close over here on the Z-Stuff relay, it grounds terminal 14 on the mini panel to ground, and the mini panel can detect that. Now, if we use the read switch like the first part of the video showed, these two wires right here, the black wire and the yellow wire, you would just connect the read switch across these two wires. And when the magnet went over the read switch, it would do the same thing as the Z-Stuff relays doing. It would close these two wires, connect these two wires together, which the mini panel would sense. The drawing for hooking up the Z-Stuff block signal detector to the Z-Stuff relay. Over here in the lower left, this sketch is copied from the Z-Stuff instruction sheet. So you can just, if you'd like, you could ignore my drawing here and just use what came with the instruction sheet. But here it shows the DZ1011 detector being hooked up to the DZ 1008 relay. And up here is the same little sketch it was on the previous drawing that shows my sketch for hooking the detector to the relay. And over here is the same sketch again, but with a terminal block, which is the way I actually assembled it. Here's the detector, and down here is the relay. And you can see we've got two wires, the red and the black, going from the track up to these two terminals here. One, I'm calling it terminals 1 and 3 for input power, and then on the output side of it we use the common on terminal 5 and the normally open terminal on terminal 6. And these two wires, the yellow and the gray, they go down to the mini panel. The gray one goes to the ground, and the yellow one goes to input terminal 14 on the mini panel, so that when the engine or a car blocks the infrared signal from the detector, which is shown here at its actual position, when something blocks that infrared signal, the Z-Stuff detector will go from green to red. It'll close the relay contacts from open. It's normally open. It'll close them. So this is your normally open terminal. Normally there's nothing here. When it closes, it'll connect the yellow to the gray, and that'll signal the mini panel that something is blocking it. Here's the command file for the commands that we enter into the mini panel. And what we're actually seeing here is an open office word processing document. This is just a word processing document I use to keep track of commands that I put into the mini panel. Let's go back up to the top for a minute where it starts. These are the configuration settings of the mini panel and a command library, and I'm not going to go into detail on these. This is stuff I use for reference, for my own reference that I need to keep straight. And where it starts is when somebody pushes the push button or closes that switch like we saw in the video. It selects the first command that says select local 101. That tells the mini panel what local we're going to command. And then this F0, F4, that basically turns, as it's done here, it turns on function 0, which is the headlights. Then it says link to input 19, so it'll go up to input 19 and perform the commands there. Let's go take a look at those. That's the main program. So here we are at input 19, and these commands are, for the most part, they're fairly straightforward and easily understandable. Our first command, now that we've selected the loco, and remember it's sitting down here, it's sitting here on the east end, starting out as you saw in the video. So we say speed forward 2, and that starts at traveling east, and then we say delay a quarter second times 52. Well, a quarter second times 52 works out to 13 seconds. So that means we do nothing for 13 seconds. It allows the loco 13 seconds to travel from the east end to get out to the west end. And of course, if we change the speed, we have to adjust the time a little bit. Now our next command is speed reverse 0. That basically says stop. There's actually a speed forward 0 command also, which is also stop. The reason I use speed reverse 0, that turns on the rear light, and I want the rear light back on as soon as possible since I had the camera position showing the rear of the locomotive. Now we have delay a quarter second times 24, which is 6 seconds. That has it sitting for 6 seconds on the east end of the layout before it starts coming back. Now the next command, we're looking at our reverse trip, point B to point A. We say speed reverse 2. That sets the loco traveling reverse, speed 2. Now we say wait until input 14 is ground. That's either our read switch or our Z-Stuff detector and relay. In either case, when the loco either goes over the read switch, or I should say the car with the magnet goes over the read switch, or the car passes in front of the Z-Stuff detector, that input will go to ground. The mini panel will know that's happened using this statement, and it'll go on to the next command. Well, that next command is speed reverse 0, and that stops the loco. And again, we have a delay quarter second times 24, which works out to 6 seconds. So it keeps it sitting on the east end here where it started out for 6 seconds. Now our next command is the one that's not so obvious. This is our test. Do we repeat that process, or do we stop? Well, if the switch is closed, that'll ground input 1, and it'll skip the next command. So it'll go down here, which is linked to input 19. So it'll go back up to input 19 and start that process all over again. So saying it another way, if that switch is kept closed, that's connected to input 1, the mini panel will keep going through this cycle of running the loco down to the east end and then waiting and then coming back. But now if the switch is open, such as if it was a push button that initiated this cycle, and somebody just pushed the button once and released it, when it comes back, that'll be open, so it won't skip this statement, and what it'll see is this end statement, terminate, which will stop the mini panel running this sequence, so the loco will just sit there, and then it'll wait until somebody comes along and pushes the button again, which will start this program running again. As I said earlier, the idea is if you're running on a public display and there's nobody there, your loco's not running back and forth, wearing itself out with no one watching. It'll sit there and wait until somebody, the public, comes in and pushes that button again to start it up again.